Hi guys, this is another video on data cleaning for machine learning, right? So once we import data, right, we scheme the data and then we spot the issues to address before exploratory data analysis and machine learning model building, right? And how we address the issues depends on the types of data that they are, right? So for example, in the previous videos, we learned to deal with or clean um, the logical variables, right? How do we clean them? Character variables, categorical variables, right? And we also looked at text variable or strings, right? And we have said that um, there are types of variables that we do not want to alter from the raw form, the way they are imported, right? But still want to explore its correlation with the target variable, right? The reason that we do not want to alter is because we want to keep the data as close to the raw form as possible. And also because in the pre-processing step, there will be another chance to make the data ready for machine learning um, using a package called recipes, right? And you might ask, why do we want to keep the data as close to the raw form as possible? Well, it will be a lot more convenient when we try to use the model that we have to make predictions and interpret, right? It will be a lot easier if the data that we use for model building is close to the original form, all right? So we learn to examine the correlation of a string variable with a target variable, right? That was on another video. This video, we're going to talk about the date variable, okay? So that's another types of variable that we do not want to alter from the raw form because, again, in the pre-processing step, we can, um, we'll have an opportunity to make this data ready for machine learning. So in the data cleaning step, we just want to examine its correlation with the target variable. Okay. So what we want to do is something like this, right? So there are different ways to examine correlation, but um, as I told you guys, correlation funnel analysis is my favorite, right? So you could have, so it's a sort of a one-stop shop, right? At the top you have the target variable, and then you can have all the potential predictors. So here, just to focus on the the date variable, I excluded all the other variables. But in the real work, you should have all the potential predictors here. I just included the date variable here just to focus on that variable. Okay. So as you can see here, it's the target variable is vote average, right? So you can see that we're using horror movie data set, right? And there's a variable called release date, right? When is the movie released to the public, right? And that release date, I extracted components of the date. So for example, release month, release year, and what day of the week was it released, weekday, right? So in this correlation funnel plot, we can see that they're not, they're all these dots here, they're very close to zero, right? So ideally, we want to see these dots outside of point two or outside or left of negative point two, right? So the fact that all these dots are close to zero vertical line here means release date doesn't seem to matter much for the movie popularity. Okay, so how do we create a plot like this? Okay, so first we need to extract the date components from the release date. So here, for all movies, there's a vote average, which is a target variable, and there's also release date, and we can see that this is a date variable, date, right? So the package that you need here, um, so this is a textbook that we use in the intro class. So R for data science, right? And then there's a chapter on date. So chapter 16, dates and times. And then section 3, date and time components and getting components, right? So in LubroDate package, um, we have all these convenient functions: year function, extracts year from a date variable, month function, right? And then month of the day, all these. So I'm gonna just take year, month, and weekday because you could have a hypothesis that a movie that was released on, say, Sunday of the week instead of Monday of the week, where everybody has to go to work, um, has a better chance for a hit, right? So let's do that. So horror movies. Oh, by the way, let's load library Lubra date, right? And control enter to load the package, right? And then let's just select, just to focus on the date variable, as I said, let's just select the target variable, which is vote average and release date, right? And then, so extract date components. So mutate release year and year function from LubraDate package and from the release date. So if you execute this, control enter, you have this vote average, release date, and release year, right? So you can see that 2022 is extracted from the release date. And we can do the same thing with the month, release month, right? Month function from the package and then from release date. And again, we do the same with release weekday, right? Weekday function. Is it weekday? Yeah, weekday. And from what variable? Release date variable, right? And control enter, right? So these are numbers, right? You can also uh, put them as factors with label. So month function, for example, here, there's a label argument, true, label, true, control enter. So now instead of numbers, we have these labels and it's ordered factors, okay? And now we can um, delete release date because if we don't, um, so in correlation funnel plot creating, the first step is what? Step one is binarize, right? So here, binarize, if we just pass this to binarize and control enter, we get this error saying binarize function. Unacceptable columns detected. The following columns contain non-numeric or non-categorical data types. So binarize function can only take numbers and factors, no date variable. Okay, so what we need to do is to deselect release date. Okay, and let's save this. Another name data binarized TDL table alt dash, right? Control enter to save this result. So now if you control C, control V, and control enter, it's hard to see like this, right? It's hard to see like this, the results. So if you have a wide table like this, use glimpse function, control enter. So now you can easily see all the variables and the data type and the first few values here, right? So you can see that our target variable vote average is put into three groups, and this is the most popular group, right? Vote of 5.7 or higher, right? Most popular movie group. So in the next step, step two, we want to find correlations, right, with this most expensive group of movies. So data binarized table, pass that to correlate function. And we want to provide this target variable. What are the variables that are correlated with the most popular movies, right? That's basically what we're doing. Control V, okay? And control enter. Now, there's correlation, right? So it turns out um, release month, January, right? Seems to have the highest correlation, right, in absolute value, but still not much, right? 0.07. We want um, potential predictors with at least 0.2 or higher in absolute value, and we don't have any here. So again, let's make a plot anyways. So data correlate TBL alt dash control enter, and again control V and control enter to print it, right? So again, it's the same thing, and we're going to pass that to a plot. Step 3 is plot. So data correlation table, pass that to plot correlation funnel function, control enter. So there we have correlation funnel plot, right? Which shows that release date, after extracting the components of the release date, we are not seeing any correlations with the target variable float average, right? Because all these are very close to 0. Okay. All right. So again, this date variable um, doesn't seem matter much. So I guess at this point, you can drop this release date variable and don't have to take it to a machine learning model. All right. Okay. I'll see you in the next video.